All right. So today, the last day of this stuff. Just as a reminder to you, on Monday we're going to start your semester review sheets. But today is the last new material of the year. So, for hyperbolas, I printed off the worksheet, which was kind of like yesterday's. The only difference is it's now hyperbolas instead of ellipses. But I got both sides of it because I felt like just might as well do it in one day instead of 2 days. Kind of like what you guys thought about the ellipses. We could have did that in 1 day instead of 2. So, first thing is, there's a couple differences, just like we had with the ellipses with hyperbolas. So there's going to be 2 different equations. First equation is going to look like this. And the second equation will look like that. So what I want you to figure out is, what did I do differently? I switched the x's and y's. Bless you. And the other thing that's different from an ellipse as compared to a hyperbola is the subtraction. Okay, notice that it's subtracting in between there rather than adding. So that's how you know the difference between the two. If it was adding in between there, we would have an ellipse. If it's subtracting, we have a hyperbola. Okay? What a hyperbola looks like, just so that you guys understand this, it looks like 2 parabolas together. And that's what it makes, is it looks like 2 parabolas going in opposite directions. That's what a hyperbola is going to look like when I draw the graphs. Okay? Now, the things that you're going to have to know, first of all, are vertices. Just like before, we had vertices. Again, the reason why it's plural is because you're going to have 2 of them. Okay? And on this first one, it's going to be plus or minus a, 0. And the reason why it's in that particular spot, if you look at it, the a is underneath the x, so therefore that's why it's in the x position. So what do you think it is for the other side? 0 and then plus or minus a, because of the fact that the a is underneath the y this time. Make sense so far? Is that a lot different from yesterday? No, not really. Okay? Just knowing which one it goes underneath. The foci, again, is another thing that we're going to have. Foci, again, remember, is plural for focus. It's still plus or minus c. But this time the equation for the foci is not c squared equals a squared minus b squared. It's c squared equals a squared plus b squared. So it is the Pythagorean theorem. Bless you. Okay? So that's how you're going to find c, is using that formula. Now, the other new part that you're going to have for this one is also going to be what we call an asymptote. Do you remember what asymptotes were? Kind of how wide it gets. The other thing is, remember when we had them for like the exponential and log ones? They were that line that it never crosses. Okay, so yes, it will be exactly what you said, Parker, where it will be how wide it gets. Okay? Yeah. And for the first one, or for them, it's plus or minus b over a and then x. And I'll show you how to get that. There's an easier way to kind of attack that rather than the formal way. Okay? I think it's easier. So there's my formulas. Okay? So here's what it's going to have you do for the first couple. For the front side, it's going to say graph. Identify all the pieces. Mises. Yeah. It has x squared over 16 minus y squared over 4 equals 1. Now, here's something that I didn't tell you on the first slide. Whichever letter is in the front, so which letter is in the front part of the equation? Good. Then that means it's going to open left or right. If y was in the front, it would open up or down. Okay, just so that you guys know that. If whatever letter's in the front is going to dictate which way it opens. Okay, so if the X is in the front, it's going to go left and right. If the Y is in the front, it's going to open up and down. I think I got it right. So here's what I need you guys to tell me. First of all, what is the square root of 16? 4. So for this particular thing, since it's underneath the X, our vertices are plus or minus 4. The other thing that I want you to figure out is I want you to figure out what the square root of that number is. Even though we're not necessarily going to use it a whole lot, but it is important for the graph part. So what's the square root of 4? 2. Now here's how the graph starts out, just so that you guys know. When you have this thing going like this, that's actually a really good one, I think. How'd I do? Pretty straight today, huh? Yeah. Okay. Since the vertices were on the x-axis, I'm going to go over 1, 2, 3, 4. 1, 2, 3, 4. And then the other ones, they're kind of like co-vertices like we had yesterday for ellipses. Just we're not going to connect them with anything. Okay? I have to go up 2, 1, 2, and down 1, 2. Now what I'm going to do to make it simple for you is I'm going to create a rectangle using those points. But I'm going to try to make it in like dash lines because it's not really in your picture. Okay? So I'm going to just connect this thing right here like so. Up 2 and down 4. So I have this box looking thingy. Okay? Now, here's the reason why I created the box. If I connect the corner to the opposite corner, like if I go from the bottom left to the upper right and connect it with a line, that's your asymptote. Okay? So it's easier, I think, in order to figure that out if you create the box. Okay? So I'll put the asymptotes in red just so you can see them, but I'm still going to put them as dashed lines. So if I connect these things right here and continue to carry them on forever, and then if I connect them over on this side, there are your asymptotes. Now, here's how they come up with it, just so that you guys know. Do you remember rise over run? How far up did we go? 2. How far over did we go? 4. What's 2 over 4 reduced to? 1/2. So my asymptote was at plus or minus 1/2 x. And how I got the plus or minus is because one goes up and the other one goes down. Does that make sense? Are you guys comfortable with how I found those?
Wait, what does that say? 1/2 what? X.
X. That's also the arrow right there. That's 1/2 x. I should have probably put it in a different color. Okay? Again, all I did was, because this was underneath the x, the 16, square root of 16 is 4, I went 4 to the right, 4 to the left. Then I square rooted 4, which gave me 2, plus or minus 2, so I went 2 up, 2 down. And then created a rectangle with those numbers. Then connected opposite corners together to make my asymptotes. Does that make sense? Now, here's the other thing. Since x was first, the vertices are right here and right here. Those are my vertices. Because the x was listed first, I darken in the x numbers, 4 and -4. If the y would have been first, I would have darkened in the 2 and the -2. But because I have the other way, that's what we end up having. For the foci, the equation I gave you was c squared equals a squared plus b squared. What's a squared? 16. What's b squared? 4. What's 16 plus 4? 20. And the square root of 20 plus or minus 2 root 5. Right? So for the foci itself, it's plus or minus 2 root 5, 0. Again, they're going to be in the same spots that your vertices were. 2 root 5 is a little bit bigger than 4, just so that you guys know. It's like 4.5 if you remember. We've had that number before the last couple days. So the foci for this one, just so that you guys know, if I put it in orange, should be out here. It should be out there. That's where the foci are going to be. Then, since you always open up to the foci, you're going to have a parabola-looking shape that goes on the right side, and a parabola-looking shape that opens up on the left side. That's what a hyperbola is going to look like. Okay, would you like to do another one? Do you want one that goes with y first? Okay. Well, how about this one? 16y squared minus 25x squared equals 400. Like we talked about the other day, as you're writing it down, can you have it equal to 400? No. What do you have to have it equal to? 1. And how do I get the 400 out of there then? Good. I divide everything by 400. When you do that, you're going to create fractions. 16 over 400 reduces down to what? So y squared over 25. 25 over 400 reduces down to what? 16, and then you have a 1 there. I hope you guys noticed that we were pretty nice to you. Do you know what I mean by nice to you? You looked at all the numbers for the most part, other than the foci, have all of the other ones, like the vertices, co-vertices like yesterday, have they all been like perfect squares? They have been. Okay, just so you know, we've been pretty nice to you. Now, the vertices. Which way are the vertices going to go for this one? Up and down. Okay, so when I write that, what's the square root of 25? So 0 and then plus or minus 5. To find the foci, it's going to be 0 and then whatever we get. Now remember, it's a squared plus b squared equals c squared. So a squared is 25. B squared is 16. What's 25 plus 16? Bless you. 41. The square root of 41, 41 is a prime number, first of all. So therefore, will it ever reduce? No. So I have plus or minus root 41. Then the asymptote. If you want to wait to make your box to do the asymptote, it might be easier. That's what I found when I was doing this for the first time. And what I mean by the box, again, what'd you get for the vertices? So that's up and down, correct? 1, 2, 3, 4, 5. Make dot. 1, 2, 3, 4, 5. Make dot. Then the other ones that we don't necessarily need, we're going to use them, but we don't necessarily need them. How far do I have to go left and right? 4. How'd you get 4? Square root of 16. 1, 2, 3, 4. Make dot. 1, 2, 3, 4. Make dot. And then if I make my box, and if I connect corners of the box together, what was the slope for that? Up 5 over 4. So plus or minus 5/4 x. So in this particular case, it wouldn't be b over a, it would have been a over b, because we will have the x or the y first. I've identified the vertices, I identified the foci, I identified the asymptote. The only thing I have left to do is to do what? Huh? That's the only thing I have left. Yeah, draw it. So how do I draw it? Which way should it open? Up and down. Why should it open up and down again? Because the y is first. And all I do is I try to ride it outside my asymptote lines. Okay, what do you think? Graphing okay? Now, the back side is going to give you some of the pieces of information. You have to come up with the equation. Sound familiar? Same thing we've been doing. So, if it tells you that the foci was 6, 0 and negative 6, 0, and the vertices were 4, 0, negative 4, 0, write the standard equation. So, something that I want you to take away from this. Remember, the vertices and the foci are going to tell you what number or what letter should go first. What position are they in? The x or the y?
Y. X.
They're in the x. When it's, remember, it's order pair of x, then y? They're in the x. So that means what letter should go first? X. So again, your generic form has x squared over I don't know minus y squared over I don't know yet equals 1. So the vertice for this was 4 or negative 4. What's 4 or negative 4 squared? 16. So I know that part. The only thing I have to figure out then is what's b squared. So the formula I gave you just a little bit ago was c squared equals a squared plus b squared. Don't get that confused with the ellipses from yesterday. Okay? It's not minus b squared on this one, it's plus. The foci is your c. What is 6 squared? 36. Equals. What's a squared again? 16 plus I don't know squared. If I subtract 16, what do I get? 20 equals b squared. Now, just like we had the other day, do you have to square root this and then end up squaring it again? No. You can just put the 20 right here and then you're done. Every single one of the ones that we're going to give you is going to give you a foci and a vertice. It's not going to give you any other piece of information. That's all it's going to give you. Would you like me to go through another one? Yes or no? No? Then the last thing that I want you to do is I'm going to give you an equation and it's going to ask you one of 4 things. Is this a parabola, circle, ellipse, or hyperbola? That's what it's going to ask you. Which one of the 4 is it? So we have 25x squared plus 4y squared equals 100. So first off, when you're looking at it, I'm going to throw away the parabola right away. Does anybody know why I throw out the parabola right away? Think back to Monday. What was so special about a parabola? It's what? No, I didn't hear you.
There's a P in it.
There's a P. Oh, yeah. There's a P in it. Yes, there is a P in it, and there isn't one like that in here. What I want you to think about is though this. Here's the first thing that I go through my thought process. A parabola had only one of them squared, not both of them squared. Right? When you're looking at this, at everything, the parabola had just one squared, not both of them squared. So this gets thrown out the window. Then the other thing, for a circle. Remember the circle formulas I gave you was x squared plus y squared equal to number squared. Right? X squared plus y squared equals r squared. And there was nothing in front of the x or the y, like 25 and 4. However, if I divide by 100, are the fractions gone? I don't know. So if I divide everything by 100, 25 over 100, that doesn't cancel out, does it? What does it give you? X over 4. And 4 over 100 doesn't cancel out. What does it give you? Over 25 equals 1. That's not a circle. A circle, remember, would have to be x squared plus y squared equals a number. Okay? It cannot have anything left over. Okay? Now you have a determination between, is it an ellipse or a hyperbola? Is that an ellipse or a hyperbola? Because they both have fractions. Why is it an ellipse? Because it's adding. Good job. So this particular thing is an ellipse. Nice work. Okay? Now, don't be fooled also. If they give you something like this, okay? If they have 4x squared plus 4y squared equals 16. Is that a parabola? No. Why not? They're both squared. So now I've got it down to one of the three. Now here's the thing. If I divide by 16, that's not going to cancel each other out, but it's going to give me the same numbers underneath both of these, isn't it? Do you notice how these are both the same? If I divide everything by that number, rather than dividing them all by 16, I get x squared plus y squared equals 4. Is that an ellipse or a hyperbola? No, because there's no fraction pieces left over. So what is it? Yep, circle gets the square. So on the last 4, they're just asking you, what type is this? And that's it. How do you feel? Besides tired?